So, okay, let us continue. So yeah, that was the last thing where we stopped then on, when was it? Last week on Thursday with the fractionated crystallization. So that means we have, I showed you this picture now a few times. We have the emplacement of a melt or magma somewhere. Then we will cool it down from outside to inside. So these minerals which are cooling down or which becomes at first removed from the melt, these are minerals which form at higher temperature. Therefore we will change frequently or continuously the chemical composition of our magma or melt. So and therefore we will then form at the end a residual melt inside the chamber. So in this residual melt, if we are starting with a basaltic melt, then we can fractionate this melt down till we are becoming a granite. Yeah? So and there we have then also the enrichment of water and some other volatiles inside and all the incompatible elements. So and there we have then these elements like copper and gold, for example, which is then very important for the formation of those ore deposits. But that is a thing for ES301. So that was the fractionate crystallization. Then we have now the next thing. We have the gravitative differentiation. So in the gravitative differentiation, that is the Stokes law, and that describes when a mineral is sinking down. So, but there we will have when a mineral is sinking down, and that can be described by V, that is the speed. Then we have 2 divided by 9. Then we have the gravitation, they make a G, multiplied by r quadrat, that is the diameter or the radius of a mineral. Multiplied by ds. ds, that is the density of the melt, minus ds of the crystal. So, and that is divided by nu, and nu is the viscosity. So these are, that is then, as I told you, the radius of a mineral. So, and that is the viscosity of the melt. So, and if we have such a melt, I told you this also a lot of times before, then minerals like orgite, olivine, are always sinking. Whereas plagioclase is sinking. Moment. Plagioclase is only sinking in very acid melts. So, and if you remember our field trip, that was, I think, the ES303, then we went there to the Sambeto river, yeah? So, and there you saw these anorthosites. So, and these anorthosites, these are then, anorthite is a plagioclase, and that was a mafic melt, and there you could see these huge anorthosites. So, and that means they were just floating up on the top of the magma chamber. So, are you done with this, yeah? So then I have here two definitions. First, something about the Bunsen theory. So the Bunsen theory means that a melt can always be described between two end members. What this means, I will show you that in a few examples. So, and then something to assimilation. The process of assimilation can only take place where melt or slash magma, yeah, it's the same, are in contact with the surrounding country rocks. So, and that you know by now, you have the emplacement somewhere of a melt or magma. So, and then you are heating up the surrounding country rocks, or you have the rise up of melt or magma, and then it's always in contact with the surrounding country rocks, and there you have assimilation. So that means some parts of the surrounding country rocks become molten, so and therefore you are changing then always the composition of your magma or melt. So I can remove this, yes. So here we have now magmatic differentiation part 2. Before it was part 1, now I have there some examples which are more going into detail or some additional informations. So first we started with liquid unmixing. So and if we have liquid unmixing, then we need at least 2 melts, yeah? And these 2 melts must be not mixable. So and there we have then, for example, and there I'm giving you now an example, that is the drop unmixing. And the drop unmixing, that is, for example, sulfide centers. Sulfide centers in carbonate. So and these are then sulfide ore deposits. You see, it's all closed. So and that looks like follows. We have here maybe such a carbonate melt or crystals. So that is just out of my imagination. So that is then such a crystal. So and then you have here your sulfide drops. So and these are your sulfide centers. That means while this was formed, you had two melts, so and these melts could not be mixed up together. Yeah? So and then you will form some isolated minerals in another minerals, and in this case, these are sulfide centers here. The next point we can put below. Then number 2, that was the next point. That was magma mixing. And magma mixing is also called hybridismus. So a hybrid means always two components. And if you have two components, that means we will then produce a banded volcanic rock. And mixing take place through convection. Here I have to add something. You can have also it is also possible to get magnetite drops in carbonatite. So in this thing now back to number 2, we have here magma mixing, and magma mixing that is always because of hybridismus. You know, there are a lot of these cars around which are called hybrid cars. And these cars are called hybrid cars because they have an electro engine and they have a fuel engine. So, and therefore we talking here about two melts, at least two melts, and then we have magma mixing, and that can end up as an example in such banded volcanic rocks. So, and this mixing took place due to convection. So, everywhere where you have a melt or a replacement of a melt, you will form then a convection cell. And that is due to the temperature gradient from core to the rim. Yep, I can remove this. So number 3, that was assimilation. And assimilation, that is the same as contamination. So, and that is then just the contact of your melt with the surrounding country rocks. So that you know by now as well. Then we had number 4, the gas transport. That is just the removal of alkalis plus SiO2 with the volatiles. So, and I gave you this example that, for example, when we are looking for the rocks in Hawaii, you know Hawaii has a volcanic chain, and I told you this last time, and you have the removal of alkalis and SiO2. So, when this alkalis and SiO2 becomes then located at the top of the magma chamber, so and therefore the older volcanic rocks in Hawaii has another chemical composition as the younger ones. Yeah, that is the differentiation in your magma chamber. So, and that is a chemical effect here. Number 5, we had the sorite diffusion. And that is just a movement of components due to temperature gradient. So if we have a temperature gradient, for example, basic components moving at high temperatures, whereas acid components moving at low temperatures. Because if you have two melts, these are the melt, balances. Or if you are making it more professional, equilibrias. So because if we have two melts, so then one melt is maybe more hot and the other one is more cold, then you will mix them up. So when the hotter melt has to come down with the temperature and the lower melt has to go up with the temperature, and then you will create some movement, yeah? So for example, we have here the lower mantle. Some melt moves up here, yeah? So and here some parts of the melts becoming removed here. So and then this melt tries then to come in contact or in equilibria with the outer parts, with the parts around. So and therefore we will create a movement between components from outside and inside, yeah? So that is a rising melt. That is the upper mantle here. Here we have the rise up of melt. Okay, you are done with this. Then number 6 again, the fractionated crystallization. So that we have a melt, and we are calling this melt, melt 1. So, and then we had crystallization take place, and then we have a melt 2 plus crystals. So, and that means then this melt has another chemical composition as melt 1. So we did this now a few times, yeah? So then we have something more in detail. Processes of differentiation of crystals and melt. So there we have at first because of floating. So, and that is then called floating differentiation. There we have one process, the filter pressing. That looks in nature like follow. You have here every sphere small particles. I'm not trembling, I will just make it more realistic. So this is then the floating differentiation. So that means if we have somewhere a lava flow, yeah. So and there, if you have a lava flow, then during the floating process, some crystals become formed and they are sinking to the ground of such a lava flow, or maybe forming a channel around, yeah? So, and if you have such a channel, and such a channel, if you are talking about lava flows, that is then called an orbido. That means you are forming a skin at the outside of your melt. So, and then you are forming a small skin. And and then you have some crystals sinking down, and then some other melt becomes then inside here in these gaps. So, and this is then called here the filter pressing. So, and if you are looking along the a-axis, then you have here such a small skin, yeah? You have here a lava flow. So, and here you are forming a small skin here, yeah? So, and that is just a cooling effect, yeah? So, and this is then called such a tornado. So these tornadoes are very dangerous. So because they are forming this small skin, and this small skin is then black here, if we have a mafic belt, and beneath this small skin you have your lava. So that is then here the lava channel. So, and here at the bottom, you are there. You will have then always also here is the bottom. Then crystals will sink to the ground. So there is then everywhere here, you are forming here a more and more a bigger or smaller layer. So in between all these gaps, some other melt will go in, and then we have this effect of filter pressing. I can remove this wonderful picture. So, then another effect under the point of fractionated crystallization, that is the dynamic wall crystallization. So what means this now? If we are talking about a wall, we need at first a wall, yeah? So and we have then somewhere, for example, the entrance or the emplacement of a melt in a channel or somewhere in a space or something like this. Then we have here a wall. So that is the wall. So that is now not a tornado as it was before. We have just somewhere in space, and the space is always surrounded by a wall, yeah? So and if we have a melt, then we are, you can just do the same experiment while you are cooking your spaghettis or other noodles. So as a wall, the wall is then a pot, yeah? A pot which you are putting on your oven, yeah? Then it looks not longer like this, then it looks like this. So, and then you are putting your water in, and then you are starting to boil your water, and you have your noodles inside. And then you have a temperature gradient in your pot. And the temperature gradient in your pot leads to form convection cells, yeah? And that goes then like this. Here it goes up because it is more hot. Then it cools down on the surface, yeah, because it's a little bit cooler, because it's open. So and then it moves here to the rim, and the rim here or the wall or from the pot is also cooler, yeah. So and then cool water is heavier than as hot water. Then it will sink down and comes up again, yeah. Looks like something like this, yeah. So and if you are now putting your noodles or spaghettis inside, then you can see that they are circulating in the water. Have you observed this? Yes. So and that's the same in nature. It's always the same. And therefore it is important to do all these calculations always in class, because it's always the same processes, and it does not matter what you are talking about, it's always the same. Because mass and physics does not change. So and if we have now the wall and we have the rise up here of a melt, then it will cool down at the wall, and then the melt will just also circulate like here, yeah? So and that's in the Earth's mantle the same when we are, and I will show it to you when we are talking about the convection cells in the Earth's mantle, and the Earth's lower mantle and the Earth's upper mantle. So, now we have this wall crystallization. So and that means crystallization will just take place here. Yep, that is because your melt cools down here, and then you will just form here crystals. That is according to Wilson. And Wilson, it's an old geologist or petrologist, the double diffusion effect. Or double diffusion convection. Effect is wrong, convection is right. So this, the thing here under the point fractionated crystallization before the floating, and here we have this wall crystallization, and then the fractionated crystallization that you have a melt, then you remove crystals, and melt number 2 has then another composition. These are all chemical processes, yeah? But now we are going back to physical processes. I can remove the pot. Of differentiation due to mass and density. So, and there where we have then just, I have just something that is then the gravitative differentiation. So, and I mentioned this before, but now I have other nice diagram. So here we have on this axis we have the density. And the density of a granite, for example, we have here granite, here we have basalt. Then we have here maybe a density of 3, and here we have a density of 2.5. So then we have here make it here. The plagioclase. And here we have the Lewisite. Is swimming. Then we have the plagioclase, and if it is an anortite-rich plagioclase, then it's also swimming. So here we have the albite, and here we have the anortite. Plagioclase is not sinking in basalt. And told you this before as well. Then we have here, for example, the orchide. And here we have the olivine. These are phases which are always sinking. That here, by the way, is curve that it describes then the identity of a mineral. So just to give it to you once more, the sinking velocity can be described in following function, that is V is, that's the same as I have given you before, 2 divided by 9 multiplied by G multiplied by the radius. Then you have the density of your melt minus the density of your crystal divided by nu, and that's the viscosity. Where R is the radius of a crystal, XX is the crystal, dm, or I have written before ds here. ds, density of the melt, dc, density of the crystal, and nu is the viscosity. And G, you know, that is the gravity. So, and the viscosity, well, yeah, the viscosity is low in basalt or basaltic melt. Therefore, a high speed of sinking can be expected. So, and that means that mafic phases are sinking. So, and then we are done for today. So then see most of you I will see tomorrow morning, yeah? But on the other hand, we can also skip the class tomorrow morning. I mean for the ES301. I think most of you are sitting in the ES301. Yes. So yeah, then let us skip this class because on the Thursday morning we will go for the field trip. So, and that was now the first part of the ES303, and that is then also the topics for the first test. So I will hand out during the field trip, I think so, the first test. And you can do this test then as a homework and handing it in 1 week later. So, but I would also have after the field trip this calculation, yeah, from the age, yeah. Yes? So.